What's up, math geeks? Harbinger here. Sorry I couldn't be there with you today. Trust me, I'd rather be in geometry right now. Instead, other fun stuff. Life happens. What are you going to do? Here's a stupid flipped video to give you some notes on nested similar right triangles. Sorry if I'm trying to get my face off the screen as fast as possible. You know, nobody wants to see that. Anyway, we're doing page 74. So page 74, please. This springs from, I gave you a math problem a while ago on your pre-assessment that said, how many triangles do you see that are similar? Now, that says how many similar triangles. That little tilde right there means similar. So triangles that are in proportion, right? So a lot of you said one or cannot be determined, but in actuality it's three. You got little guy, you've got medium, and you've got the big one on the outside. So there are three similar triangles as a heads up. And we're going to use that a lot. So you're often given two possibilities. Their triangle can look like you've got a leg and another partial thing and this other guy that's kind of in the middle. That's one way. That's the nice way. Here's why. These are notes. I don't necessarily abide by these. Left bottom over altitude is altitude over right bottom. Boo. Nobody's going to remember that. For me, I usually go big over small is big over small because that's easy, and I'll show you what that looks like in a better picture in a minute. But really what this is saying is I need four things to make a proportion, and you're usually given three, which means it's often doubled up. So 5 over x is x over 16. That's this side over this dude in the middle equals dude in the middle over this side. This is really like small over big is small over big. So small side of small triangle over the bigger leg. And then if you look at medium triangle, this is the smaller leg over the bigger leg. I'm not talking about the diagonals, those are the hypotenuses. But anyway, it's 5 over x is x over 16. Now here's the fun thing about this. We're going to cross multiply. And I can't leave it like x squared. Nobody cares about x squared. I like radical 80. Now, if it says in simplest radical form or something like that, then we got to simplify the radical. But in reality, you're not really tested on your ability to simplify radicals. You did that in Math 8 probably, and Algebra 1, but sometimes it might say nearest tenth, and you would just put this in your calculator. What I really like about this is if you get it wrong, you know in a hurry. So I'll leave a note here like, wrong. Maybe you set it up wrong. Maybe you're like, oh, x over 5, right? Because I got this x on top of a 5, and there's an x on top of a 16. And maybe you do it like this, right? So we all know that if this was the Regents, we'd be talking about, well, one way is full credit, and the other way would be half credit. But if you cross multiply, 5x equals 16x, what? That's like saying 5 times something is 16 times that same thing. Oh my gosh, if I subtract 5x from both sides, I get x is 0, and that doesn't make any sense. So if you get an answer that doesn't make sense, you know you set it up wrong in the first place. So doesn't make sense, which means stop and do it a different way. So maybe you did x over 5 is x over 16. Oh my gosh, I did it wrong. I better go fix things, and you set it up like this. Maybe you flip one of them upside down, right? Maybe you flip the 16 over x instead. Then you'd get it right. So you either do it wrong and you get half credit, and then you make it better to get full credit, or you do it better in the first place. So this is self-correcting. Be careful. If you get something that doesn't make sense, please flip one of them and go again. So you try number 2, find x. I set it up. I said, hey, 4 over x is x over 5. Same exact deal, right? X squared is 20 and x is radical 20. And if you're good at simplifying radicals, I don't do the tree way, and I think some of you do, and that's cool. But I just break down the radical like it's supposed to be broken down. Hey, 2 radical 5. So same deal with this dude on the right. I just don't feel like doing the same problem over and over and over. What, 2 over 6 is 6 over x? I bet a lot of you do really well with that. Right, you don't always have to square root. I guess I will do the same problem over and over. So 36 equals 2x. And hey, 18 is x. Right, if you get something that doesn't make sense, like -4 or 1 in the context of the problem looks a little bit weird, you might want to check your work. But in truth, I didn't get 0, so I'm kind of happy with what I got. Now this guy's different. You and I know you got to break it into 30 and 10, right? If this guy's 10 and the whole thing is 40, you can write down everything you know and then do the setup. I'm not doing that one right there. I trust in your abilities. Anyway, like I said, there's two possibilities. There's the one where it's the biggest side is split by an altitude, right? And that's where you do the 4 over x is x over 5 kind of thing. And then there's the other one. Now, what I don't do is say little, big, because that doesn't make any sense. To me, there are teachers who explain this really well and it makes a whole lot of sense. But for me, I'm not doing it that way. So I typically say, well, how about 4? And if you see the arrows, that actually helps a lot. 4 over x is x over, oh my gosh, the big side, 9. So this is kind of helpful. If you're looking at it, that's like saying leg over hypotenuse, right? Because a right triangle has 2 legs and a hypotenuse. So it's got leg, it's got another leg, and it's got the hypotenuse. You know that because the right angle is right there and it's across the right angle. So leg of little triangle, that guy, leg is 4, hypotenuse is x, equals, and if you think about the big triangle, talking about big guy, then we're talking about, gee, how big is the leg on that one? The leg is x, and the hypotenuse is 9. A lot of people goof that up. So it's okay to say, leg over height equals leg of this guy over height. Hey, the leg of one triangle is 4, and its hypotenuse is x, and then that x is also the leg of a different triangle. It's not always the leg of something. It's not always the hypotenuse of something. In this case, the hypo little guy is the leg of the big one. That's fine. Anyway, x squared equals 36. Hey, x is 6. I got something that makes sense. I'm a happy guy. In truth, I'm mean enough that I would make you solve for the altitude, but we're not doing that yet. It's just Pythagorean theorem, right? Like 4 squared plus something squared equals 6 squared. We're not there yet. These two over here, I'm going to say, hey, I don't have the altitude, so I'm going to say that leg over height equals leg over height, and that would be the leg is 4 over height, which is x, and then I'm looking at the big triangle, and the leg is x over the hypotenuse, which is 25, right? The entire triangle here has the biggest side of 25. And that way when I cross multiply, I'm sitting at x squared equals 100. Hey, x is radical 100, so x is 10. And this one over here, I understand why people goof up, right? You're not given an altitude, so again, it's leg over height is leg over height. So I'm going to do the leg, 5, I'll write that down. Leg over height is leg over height, just to kind of help guide things. So the leg is 5 and the hypotenuse is 10. And then when I'm looking at the huge triangle, the leg is 10 and the hypotenuse is the entire side. It's not 5x. Everybody puts 5x. It's 5 plus x, right? It's 5 and x gives you 5 plus x. So when I cross multiply, I get 10 times 10. I'll even show all the cross multiplying equals 5 times 5 plus x. Hey, that's 100. And people are kind of lousy at distributive property, so be really careful. 5 times 5 is 25, and 5 times x is 5x. And then when I can bring the 25 over, I get 75 equals 5x. And I could just divide both sides by 5, right? So 15 is x. If you get something that doesn't make sense, you might want to go back and check your work, right? If you said like 5x here, and you said, oh, 100 equals 25x, you divide both sides by 25 and you get 4. Look, I know that's an answer that kind of works, but you're looking at it and you're thinking, gee, that's not quite right. You should probably go back and look at what you did wrong. Heads up though, if you said this was 5x and you put a 5x here and you have a 5x and you get like 4 as an answer, you still get half credit in the Regents. So the Regents is going to look at, did you set up a proportion and did you solve? And if you set up a wrong proportion but solved, great. If you just set up a wrong proportion, if you said 5 over 10 is 10 over 5x, and you stopped, you get a 0. But if you have a 5x here and you continued, you get a 1 and a 2. So not that I am all about like, here's how to get 100 on the Regents. It would just be nice. But just so you know how you're graded, it's typically a 2-pointer. You gotta set up an equation, you gotta solve. It's usually how we break the points. So I'm flipping. I'm not gonna do these. I trust in your ability to kind of set things up, right? Leg over hypotenuse is leg over hypotenuse. This one's backwards. So you've got a triangle with 2 things, and you've got the big triangle with 2 things. You're always looking for which 2 triangles have 2 pieces of information. So the leg is 8 and the height is 12. And then the big one, the leg is 12 and the height is x plus 8. Be super careful, please. That one can be tricky because you're not used to something being on the other side of things. Anyway, that's what we're doing all day today. You are being really careful about which setup is which. You know, do you have the altitude? Because then that guy happens twice. Or do you not have the altitude where you care about that dude being on both diagonals? But remember, every single time, almost every single time I can think of, you're going to have the same thing on 2 different spots. That's okay. Good luck. We've got some practice stuff to do. I'll be back there on Friday. We'll be partying like it's 1999. Not true, 1999 wasn't that much fun. We'll be partying like it's geometry class. That's way more fun than 1999. So, hope your holidays are going well. See you soon. Please be good for the substitute.